Okay, hello, and it's Science with Brian here. This is a weighted ball. I think it's got sand in it, and it represents the globe. Okay, so this is the globe Earth. This is a plate, and it represents the flat Earth with the ice wall around of it, which kind of goes up a little bit. So, this is the flat Earth. This is the globe Earth. And this is an airplane. We are not denying the existence of an airplane. Airplane over a flat Earth, airplane over a globe Earth. So, what I'm getting at here is, have you ever seen an airplane flying over the horizon and seen what looks like it's flying straight downwards? This would actually happen on a globe Earth. So let me say we're on the surface here. Now this is actually a lot higher than the surface, but, okay, that's not the idea. So here's an airplane. You can look up, you can see the airplane here. Okay, now we're flying over the curvature of the Earth. Keep in mind this is still aligned with the ground. So we're basically, we're curving around the globe, and you can see it's going what looks like down at an angle. And this is what we observe in real life. We see planes go over the horizon down at an angle. When you see a plane coming over the horizon, it looks like it's coming up at an angle, levels out right above you, and then it dips back down at an angle again. So it goes like that. And this is what we observe exactly. On a flat Earth, though, if what we observe is true, this plane is flying over us right now, it's curving, it crashes. This is definitely not what we observe. We do not observe planes crashing into the ground. We observe planes going over a curve like this. And keep in mind, this is not scale, obviously, but this is still what you would observe. You'd observe it going over a curve. Now, say I'm flying west on this globe, and let's say right here is the North Pole, so right here is our west direction. That is flying directly above us, and now it's curving around the horizon, and we are observing it go down, or what looks like down. It's really not down, though, because flat earthers can't get this right. Just because down is in this direction if you're standing right here doesn't mean down is in the same direction if you're standing right here. Because down is towards the center of the globe, down is not down the same for you on like the entire Earth, because if you're standing here, you know which direction is down, but it's not going to be the same down as here. So, I was actually arguing with a flat earther about this the other day. It says if you put a pin here and you put a pin here, the elevation is going to be different. It's really not, because the entire elevation, if you're at sea level, is going to be the exact same. Anyway, that's not really what we're demonstrating here. So you can clearly see that is what we observe on a globe. And that is actually what we observe in real life, too. So our observations match what we expect from a globe. Now let's look at a flat disk. So if a flat disk has a westward direction that's in a circle like that, I guess, because that's what most of the models are. Anyway, if we are to be flying west, you would be seeing a plane constantly rolling to the right, because if the plane is constantly rolling to the right, then that means it would be going around the Earth in a round.